Okay, this is lesson 100 in Algebra 2. Let's call it 100A, graphs of parabolas. And we're going to kind of jump a little bit into some things that we haven't done, so it'll probably take a couple videos. At this point, a couple things that you have learned is you've learned how to graph a straight line, and you've learned how to recognize the graph of a straight line. There's a straight line, but the equation of that would be something along the line of 3x plus y equals 6. Okay, so I just made that equation up just to say that this is a graph of a straight line. Not necessarily this one, but it's a graph of a straight line because the exponent on the x and the exponent on the y is 1, and the x and the y are added together, or they can be subtracted. They cannot be multiplied. It's not going to give you a straight line, but when they're added or subtracted to each other, you get a straight line. And there's an x and a y. There's two variables, just like there's a y-axis and an x-axis. If there were just x's in there or just y's, you couldn't graph it on the coordinate plane with the x-y axis like we have there. Alright, but what we're going to do now is we're going to see what a quadratic equation looks like when we graph it. And it is actually called a parabola. So it's going to look like that, or it may look like that. Okay? It will not go this way or this way. Those are hyperbolas. This is parabolas. We'll get into hyperbolas later. College algebra. Alright, so when we have a quadratic equation such as y squared, or just, let's make it just y equals x squared plus 4x plus 4. Now with that, you can make your xy axis, you can plug in a number for x, and it will spit out a y. Okay, 0 squared plus 4 times 0 plus 4. You can put any numbers you want in there and it'll spit out a y. And if you graph each one of these coordinates on the graph, it will give you a parabola. You know, like I said, it looks like this, or it looks like that. Okay, but not both at the same time. Alright, so that using the table, like right here, is kind of a pain in the neck to do. So there are some ways in order to graph parabolas given the equation so that you don't have to use the tables. Okay, so for instance, if I have y equals x squared plus 4x plus 4, or y equals negative x squared plus 4x plus 4, they're going to give me two different graphs, because the only difference between those two graphs is the x squared, and one of them is negative and one of them is positive. If you have a square root that's positive, or if you have an x squared that's positive, it will open up. If it has a negative, it will open down. So that determines whether it opens up or down. Okay, so easy enough. You can just look at it and know just from the picture whether it's going to open up or down. The question is, where is it going to be? Is it going to, I mean, this one that opens up, is it going to be here? Is it going to be here? Is it going to be here? I mean, where is it going to be? Okay, and that's what we'll do next, is we'll come up with figuring out where that parabola is on the graph. So let's get rid of these. Let's move the graph over, and let's start coming up with some things. Alright, so for one thing, whoops, let me get rid of that, get my graph back. One of the things about parabolas is they're symmetrical, meaning there is an imaginary line that goes right down the stinking middle of the thing. And so if we're going from here to here and here to here, these distances are going to be the exact same. This part reflects across this dotted line here over on top of this. Okay, so if we know any of these points here, we can figure out where they are here just by counting along this line how far we went over to get here and how far we went over to get here. Alright, so this blue dotted line here is called the axis of symmetry. Not cemetery, symmetry. Okay, that's what makes it symmetrical. Alright, so if we can find that axis of symmetry, then we found a lot of good stuff. The other thing that we want to find is we want to find that point right there called the vertex. So we want to find that, and we also want to find where this thing sits on this graph, because in a perfect world it would sit right there on the origin, the vertex would, and it would be symmetrical with the y-axis. Well, so most of them are going to be moved over here, moved down, or moved up. So we have to know what to do with that, given the equation on whether it's moved, where it's going to be moved to. So again, let's get this out of the way and see what we can do. So on page 414, it gives you some rules or a list of relationships here with the parabola. So let's go ahead and put that on here. And first thing we talked about was the vertical line, the axis of symmetry. That was number 1. Number 2, we talked about whether it opens up or down depending on whether the x squared was a positive or a negative number. And the third part is, where does the parabola cross the y-axis? Alright, so when I'm given a quadratic equation that's written like this, in this order, this number right here that's all by itself is where it crosses the y-axis. In this case, I've got it in the wrong place, but that's what that number represents. It would cross 1, 2, 3. It would cross right there of this actual equation here. So it would maybe look like that. It's not the vertex. It's just where it crosses the y-axis. All right. So that's the third part of this. So if I have y equals x squared plus 4x plus 4, this parabola is going to cross right there. Okay. If I were to change that to -2, it would cross it here. The parabola would be the exact same. It would just be down lower to where it crossed at -2. If this were a positive 6, it would be crossing right there. So it would be the exact same parabola, just shifted up or down depending on what that number right there is. So remember when I said we have an axis of symmetry? Okay, that's kind of the halfway point there. If I want to find that, and if I want to find the vertex, then there's a certain method in order to do that, and that's what we're going to do right now. So at this point, you found out whether it opens up or down. You found out you need the axis of symmetry, and you've also found out where it's going to cross the y-axis. So if we take a quadratic equation and we make a change in it so that we complete the square, which we've already done, but we'll go into it again, and we change our quadratic equation to look like this, when, maybe at one time it looked like, maybe when we first got it, it looked like this. Okay, and we changed what it looked like. We didn't change anything else except what it looked like. So it looked like that. We can use that boxed equation in order to find out more stuff about this parabola that we have. Okay, so let's look and see what we've got here. This negative sign here tells me that it's going to open that way. It's going to open down. What else do we have? This number right here, the opposite of this number right here, is my axis of symmetry. So that would be where that would go straight down. So if I had my graph over here, it would be at -4. 1, 2, 3, 4. That would be my axis of symmetry. Alright, where they get that -4 is, it's not the opposite of this 4 necessarily. It's what can I put in here for x that's going to make x plus 4 0. So -4 plus 4 is 0. So that's what I'm trying to do. So it's always going to be the opposite of this. So if this were a negative 4, it would be positive 4 minus 4 is 0. If it's positive 4, it would be negative 4 plus 4 is 0. So whatever makes this 0 is my axis of symmetry. This tells me my vertex, my y part of my vertex. So see what happens here? If this is at negative 4, my axis of symmetry, and it opens down, this number right there, that 3, tells me that my vertex is at y equals 3. 1, 2, 3. Alright, so it tells me it's going to be at y equals 3. So it's going to, I went up 3. So this axis of symmetry tells me where my x value is, how far over this way or how far over this way it is, but it doesn't tell me how far up or down. This number tells me how far up or down it is. So I know then that my vertex is there, it opens down, and it's going to look something like that. Now later on we'll figure out how to tell how wide it is. I mean, is it going to be like this or is it going to be like this? Right now that doesn't matter. We just are caring about the vertex, the axis of symmetry, and whether it opens up or down. Okay? We can also find out in the original equation where it's going to cross the y-axis. So we'll get to all that in a minute. So I'm at 11 minutes 30 some seconds. I'm going to stop here and start another video, 100B.